Hello everybody, welcome to the Law of Sines proof video. What we're first going to talk about here are two cases, two different oblique triangles. One where the angle A is acute and one where angle A is obtuse. So let's draw out those triangles first. Sorry for that background noise if you can hear that dog barking. Not much I can do about it at the moment, though. I hope it's not too intruding here. Alright, these are the basic shapes we're going to draw. The two triangles, where angle A is the leftmost, or I should say leftmost bottom angle, right? Angle A. Here angle A is acute, here angle A is obtuse. And then we can go ahead and label the other angles and sides. Angle B, angle B, angle C, side A, side B, side C. And like we've talked about in class, we know the side lengths because they are directly opposite from their angle, right? Angle B, side B, angle A, side A, angle C, side C. Okay. The next thing we're going to draw about these triangles are their heights. So in this triangle where A is acute, we're going to draw a line directly down from C, and we're going to create a right triangle by doing that, and we're going to call that the height of our triangle. For when A is obtuse, we aren't going to do anything in the middle of our triangle. We're going to go here on the outside to show H. Down from C again, and out from A, and we see that this is the height of this obtuse A triangle. From both of these, we can conclude some things. Sine of A in both of these, sine of A is, in this right triangle we've created here, sine of A is going to be opposite H over hypotenuse B. And you'll see the same thing is true here. In this right triangle we've created, opposite H over hypotenuse B, H over B. Sine of angle B over here in this right triangle is going to be H over A. Over here, this right triangle that we're looking at, it's kind of included in this extended version, is opposite of B, H over hypotenuse A. H over A. So what we can do from both of these is make statements about H. From here we can say multiply both sides by B, and H is B sine of A. Over here we can say H is A sine of B. And like we've done before, you've done this a lot in algebra, we have two equations that are equal to the same thing. And whenever that happens, you're allowed to set those two things equal to each other, right? We can make H equal to H essentially, and set B sine A equal to A sine B. And what we can do now quickly is divide both sides by AB. And what happens there is the A's cancel on the right, the B's cancel on the left, and we've arrived at the first half of the law of sines, right? Sine A over A equals sine B over B. That's recognizable. To get the sine C over C, we're going to start with those same triangles as before, but we're going to draw them in just a slightly different way. So I'm going to get a new sheet of paper here. I'm going to draw, once again, my acute A triangle. I know that I make this look isosceles, but just take my word for it, it's not. Even though it looks a little isosceles, it really isn't. And I would identify it as such if it were, right? But it's not. Okay. And so what I'm going to do here this time is I'm not going to identify H as down the middle from C. What I'm going to do instead is I'm going to do an altitude here. Let me label my sides as well. I'm going to do an altitude from angle B out to side B. And I'm going to create a 90-degree angle that way. And on my obtuse A triangle, the one that looks kind of like this, kind of funkier, right? I'm going to label those sides once more. A, B, C, side A, side B, side C. Okay. What I'm going to do there is I'm not going to draw H out here on the left. I'm going to draw it out here kind of on top, which is still fair. It's still true that this length I'm drawing up here, this is still the height of the triangle. It's just kind of a different way to arrive at it. And now what I can conclude from both of these is what sine of C is. Sine of angle C. When I look at both of these triangles now, sine of C, here's angle C in this right triangle that I've created. Sine of C, opposite H over hypotenuse A. Over here in this right triangle, opposite this length here, H. I didn't label that before. Let me do that now. The altitude I drew is also H, correct? Over hypotenuse A. H over A. So in both cases it fits. The next thing I'm going to talk about is sine of A. Sine of A for both of these. And sine of A is true. It's the same ratio for both of these triangles, but it's not really clear visually yet. Let's draw a little bit more onto our triangles first. I'm going to draw another way to determine the height of this triangle over here where A is acute. Draw this in as well. I'm going to say that this is the height. If I draw a triangle out extending from angle B up, angle C out, that's also a way to arrive at the height. It's a true way to arrive at the height. For the acute angle, the obtuse angle A, another way to talk about the height is to extend out from angle A and extend out from angle B. And now, when I create that right triangle and that right angle, right from A and from B, I've also arrived at the height here. Just another way to talk about the same height of this triangle. This is kind of, I'm not the greatest artist, I guess that's why it's a good thing you label, but this is the height as well. And now I can see sine of A in both of these cases here. When I take a look at angle A right here, I know that if I do sine of this, it's going to be the opposite side, H, over the hypotenuse, C. I suppose this wasn't necessary in the end. That's okay. And over here, when I look at this right triangle over here at the bottom, angle A, the opposite of it is H over the hypotenuse C, H over C. And now what I'm going to do is what I did last time. I'm going to write out equations for H for both of these. Let's do that right over here. For the first one, H is the same as saying A sine of C. For the second one, H is the same as saying C sine A. And just like before, now that I have two equations for H, I set them both equal to each other. A sine C equals C sine A. And again, similar to last time, I divide both sides by AC. The A's cancel on the left, the C's cancel on the right, I get sine of C over C equals sine of A over A. And we actually have another equation for sine of A, right? And so what we can use is the transitive property to say that all of those things are equal to each other. That sine of A over A is equal to sine of B over B is equal to sine of C over C. And that is the law of sines. Thank you for watching.